All right, let's get started on this review. Rational functions and some algebra. You can use your calculator on the whole thing. Way back in the beginning, we did just the transformations from the parent graph. The top number controls the vertical stretch. So if you have a number up there, then you have a vertical stretch. If the number's in the denominator, then you have a vertical shrink. So this is a vertical stretch of 3. The number adding or subtracting in the denominator controls left or right, and of course plus is left 2. And the little stick out number right here is always up or down. That's a minus, so it's down 5. If that was not something you can do, put it in the calculator. Look at the picture. You will see that it moves left 2 and down 5. The vertical stretch is a little bit harder to see, but you'll definitely do the left 2 down 5. So if you think about left 2, that is your vertical asymptote. So that's at x equals -2. And if you think about down 5, that's your horizontal asymptote, which is y equals -5. Now you will have one of these graphs to draw and to find the parts for. First thing you got to do is factor it. So the numerator, 10 to get to 3. So x plus 5 and x minus 2. Denominator is a difference of 2 squares. X minus 2 times x plus 2. Ooh, looks like we do have a whole. So you set that factor equal to 0. We get x equals 2. So we have a whole at x equals 2. So you want to remove that. So we're going to graph this or put this in the calculator. We are now just looking at this, x plus 5 over x plus 2. Vertical asymptote, set the denominator equal to 0. So x plus 2 equals 0, so we get x equals -2. That is a line, and it should be written like that. Horizontal asymptote, we have degree of 1, degree of 1. Those are highest degrees in the top and bottom, so we look at their lead coefficients. So we get y equals 1. X-intercept, set the top equal to 0. So we get x equals -5. Now you don't want to write it like that. That is a point. So it is the point -5, 0. And then the y-intercept, you make all the x's 0. Now remember, we're using this one. So we get 0 plus 5 over 0 plus 2. So that is 5/2, or 2.5. Now that's the y value. X is 0. Y is 2.5. I'm going to put these on the graph. We'll deal with the whole in a minute. We'll do that one last. So we have the vertical asymptote at -2. Make sure your asymptotes are on your graph. If they are not, your graph is not complete. Horizontal. Again, look at the calculator for verification. We have an x-intercept at -5, a y-intercept at 2.5. So if you're not sure where to draw the branches, again, look at the calculator. Using the asymptotes as guidelines and the intercepts sort of help you figure out how to draw that. And then for the whole, we'll go to where x equals 2, line that up with your solid line, and just sort of circle it where they meet, where your line meets x equals 2. That's it. There's your whole graph. The rest of the test is algebra. So we are asked to do whatever this says to perform the indicated operation. So expect adding, subtracting, multiplying, dividing, solving. We'll get to the inequalities there on the back. So you're not going to come up with an answer like x equals 5 or anything here. We're just going to combine these two. So we need the common denominator. So this is x minus 2, x plus 2. You need one of each thing. So our common denominator is going to be just that, x minus 2, x plus 2. Well, this already has an x minus 2, so we're going to multiply this one by x plus 2. Whatever you do to the bottom, you do to the top. So the first one's fine. The first one's going to say 2x plus 1. Now I would take this -5 and do it all in one step. Distribute that -5. So we get -5x minus 10. The only thing left to do is combine like terms on the top, see if anything will cancel. So 2x minus 5x, -3x, +1 and a -10, that's a -9. That factors. X minus 2x plus 2. These have a -3 in common, but nothing's going to cancel. So you don't have to factor that out. Either answer is fine. Either one of these. Because nothing cancels, so you don't have to simplify it. Number 4. Dividing. We're going to just factor, cancel. So the numerator, y minus 6, y plus 6. This denominator, we're going to add to get 8, multiply to get 16, add to get 8, so y minus 4 and another y minus 4. Second fraction gets flipped over, so I'm going to do this top part first. They have a 3 in common, so that's going to go to the bottom. And then the numerator, multiply to get 12, so 3 times 4. And we want that to be a -1, so there we go, -4, +3. Anything on the top cancels with anything on the bottom as long as they match. So y minus 4, y minus 6. That looks like it's it. So on the top, we'll have y plus 6 times y plus 3. And the bottom is 3 times y minus 4. For this last one here in this group, we're going to come up with some answers. Which means we're going to, because it has an equal sign in it, we have to multiply by the common denominator. So let's see what's in here. So that denominator is x times x plus 6. So that will be our common denominator. You need one of each factor, which means we need an x and an x plus 6. So I'm going to go back through. I'm going to rewrite this so you can see it. I'm going to multiply each and every part by the common denominator. So this gets multiplied by x times x plus 6. This one gets multiplied by x times x plus 6. And you don't have to do this part if you can see it, but I just want to go through this carefully and show you. Now what happens is some things cancel. So like here the x's cancel. So we're left with 6 times x plus 6. Here, everything cancels, so you're just left with -1. On the other side of the equal sign, the x's cancel, and we're left with x plus 6. So essentially what happens is the fraction is eliminated. So now I'm going to take it over here. Distribute that 6 minus 1 equals x plus 6. Combine like terms, so this makes it 6x plus 35. I'm going to put the x's over here, so that's a 5x. I'm going to subtract the 35. So this equals -29 and divide by 5. So we get x equals -29 over 5. Now you want to check that with the bottom and make sure that doesn't create a 0 in your original problem, which of course this is not going to because it doesn't cancel or make a 0 any of those denominators. Inequalities. We've got 2 types. Both require a number line. Both require interval notation as their answer. The first kind, you put all the answers on the graph. The second kind, you do not. All right, so let's go through this. So we're going to make this thing set equal to 0. X to the third minus 5x squared minus 9x plus 45. Set it equal to 0 and factor it. 4, so we're going to factor by grouping. First two have x squared in common, leaves you with x minus 5. That second group starts with a negative, so we're going to factor out a -9, and then that leaves you with x minus 5. The common factor is x minus 5. Pull that out. And we're left with x squared minus 9. Come up with your answers. So we get x equals 5, and square root of 9 is positive and negative 3. These numbers go on the number line in order, small to large. Negative 3, positive 3, positive 5. They all use that symbol from the problem, which means they're all going to be closed because there's a line under it. Then you select a number that's not on the line to test a section. I'm going to select 0, and 0 lives right here. I'm going to put that back into the original. No matter what else has happened in the problem, use the original. So 0 minus 0, this will be a 0. So essentially we end up with 0 is less than or equal to negative 45. That's not true. So this does not work, which means these sections do, and this section does not. So then the answer would be negative infinity to negative 3 union 3 to 5. Same thing here with number 7. Get this thing set equal to 0. X to the third minus x squared minus 4x plus 4 equals 0. Again, 4, so we're going to group this up. First, we have x squared in common. Second, we have a negative 4 in common. Leaves you with x minus 1. This feels a lot like the first one. X minus 1 comes out, and we're left with, from left to right, x squared minus 4. So the answers are 1 and positive and negative 2. Number line. Negative 2, 1, 2. I'm going to again select x equals 0, and that lives right here. Going back to the original, 0, 0, 0. So we're left with this statement, 0 is greater than negative 4. That's true. So that means this section works. No, no, yes. Now I didn't color in my points yet, so I'll do that. They use the original symbol, which is all open. So let's translate this into some interval notation. Negative 2 to 1, and we'll join that up with 2 to infinity. Now the inequality with the rationals. Factor it and cancel it. The wholes have to be removed. This first one is weird. The next one is better. So I'll just talk you through it here. They have, this top part has a 2x in common, and it leaves you with x squared minus 2. The bottom has an x squared in common, and that leaves with 3x plus 4. Now what's weird about this is that these cancel, and it stays. So x equals 0 is gone, which means that's a whole because it's a common factor, but it's still there. So the fact that x equals 0 is still there, that's this guy, we have to put it on the number line. So it's a little bit weird, it's a little bit conflicting. Is it a 0? Is it not a 0? It's a whole. It's definitely a 0, so we're going to have to leave it on the graph because it's still there. So we're going to set the top. The top gets the original symbol. So we get x squared minus 2. That's allowed to be 0. And we get positive and negative radical 2. That's all right. Now the bottom is not allowed to be 0. So x is not allowed to be 0. And 3x plus 4 is not allowed to be 0. So we get x cannot equal negative 4/3. Now this is tricky to put on the number line. We've got a lot of numbers that are close together, and that's all right. Radical 2 is 1.4-ish. Negative 4/3, that's about negative 1.3 repeating. So when we put these on the number line, these are really close together. You don't have to space them out any particular way. A negative radical 2 is the smallest number. Then we have negative 4/3, then the 0, and then we get into the positive radical 2. The top uses the original symbol. So the answers we got from the top, these are going to be closed because the original symbol has a line under it. The bottom is open because it's not allowed to be those, right? It's not allowed to equal 0, open. It's not allowed to equal -4/3, open. All right. Now, when you go pick your test point, which we cannot pick 0, we're going to use the original. Not the factored out one, but the original. I'm going to pick x equals 1. And we plug the 1 in there, and we get 2 minus 4. I'm looking at the very top, I'm all the way up here. And then 3 plus 4. And your question is that greater than or equal to 0? So we get -2 over 7. Is that greater than or equal to 0? Well, no, it's not. So this does not work. And then we just go through and do every other. Then you translate your number line into interval notation. -infinity to -2. That's joined up with -4/3 to 0. And then we join that up with (2) to infinity. That's a tricky problem. Number 9 is a little bit more realistic and more like what you can expect from the test. Factor out the numerator. Ooh, four terms. We got to group this up. So the first two have x squared in common. That leaves you with x minus 5. Now, because it's factored by grouping, we have to force this to happen. They have a -1 in common. Usually factoring out of 1 is not something we would do, but in grouping, you have to do it that way. So this is going to also be an x minus 5. The denominator, a little bit more straightforward. Multiply to get 10. And then add them to get a -3. So x minus 5, x plus 2. We're going to factor out this numerator again. X minus 5 comes out, leaving you with x squared minus 1. I'm just going to leave it like that. The bottom is the same. And we have a hole in the graph, so that has to come out. So that's gone. Don't even look at it. Don't put it on the number line. We don't talk about it anymore. It's gone. So we set the top equal to 0. So we get x squared equals 1. So x is allowed to be positive and -1. When we set the bottom not equal to 0, so x is not allowed to equal -2. The top uses the original symbol, so everything's going to be open on this graph. So the smallest number is -2, then -1, then 1. They're all open. Select a test point, which I'm going to pick 0. 0 lives between the positive and the negative. We go back up to the original. The original, the only place that has that inequality. So this is going to be, all those x's are 0, so you end up with 5. All these x's are 0s, so we end up with -10 on the bottom. Is that greater than 0? -1/2? No. Negative number is not bigger than 0, so that's a no. Yes, yes, no. And then, of course, your answer. So we have -2 to -1, and then that gets joined with 1 to infinity.